Currently, many influencers on platforms like YouTube discuss a serious topics such as health, education, finance, law, and maybe cybersecurity in manner that suggests they are expert. However, not all of them have adequate competence or credentials. And this is really dangerous because it can lead to wrong public decision, spreading misinformation, and even endanger the health or financial condition of the community. Hello, my name is Ferdi, and I created Pseudo-Expert detection system to identify influencers who have the potential to cause misguided or dangerous public decision on YouTube. I've designed a multi-layer risk assessment algorithm in 5 layers, which is content analysis, credential verification, behavioral pattern, audience response, and risk aggregation.
This algorithm accepts YouTube video URL as input. The data is collected using the YouTube API, then we analyze it using a multi-layer approaches. A multi-layer approach was chosen because it is more comprehensive and balanced. Each layer has a different weight according to its level of importance, so that the system does not depend on a single indicator and remains easy to interpret.
The first layer is content analysis, which aims to analyze the content of video to detect exaggerated claims and red flags. The algorithm begins with domain classification, which classify content into sensitive domains such as health, finance, law, cybersecurity, and education based on keyword. If the number of sensitive keywords is low, the content is considered non-sensitive with low risk. However, if it belongs to a sensitive domain, the analysis continues. Next, red flag detection is performed, such as claims of certain cure, no risk, or conspirational narratives. Then the system detects absolute claim, such as 100%, guaranteed, or always. As a counterbalance, the system also checks for good practice, such as the presence of disclaimers and scientific sources. The final score for this layer is calculated based on the number of red flags and absolute claims, then reduced if there are valid disclaimer or sources. The second layer is credential verification, which verifies whether the creator has credential relevance to the topic being discussed. The system extracts information about education, profession, and affiliation from the channel description using regex pattern matching. After that, a relevance check is performed, which matches credential with the video domain. For example, health topics should ideally be supported by a medical background. If a sensitive topic is discussed without credential, the risk score will be high. Conversely, if the credentials are relevant and verified, the risk becomes low. The system also gives additional penalties for false credential claims, such as calling oneself an expert without concrete evidence. The third layer analyzes channel behavior patterns. First, a modified channel diversity index-based topic diversity index is used. Channels that frequently switch between sensitive topics are considered more suspicious. Second, clickbait detection is performed based on excessive use of capital letters, extreme punctuation, and clickbait keywords. Third, the system analyzes video duration. For serious topics, videos that are too short are considered risky because they are lack depth. Finally, upload patterns are analyzed to determine consistency and frequency. All of those indicators are combined to generate a channel behavior risk score. Finally, upload patterns are analyzed to determine consistency and frequency. All of these indicators are combined to generate a channel behavior risk score. The fourth layer is audience response analysis, which utilizes the wisdom of the crowd. Comments are analyzed using sentiment analysis to measure the proportion of positive, negative, and neutral sentiments. The system also detects critical comments, such as those questioning the source credentials or accuracy of information. In addition, engagement anomaly detection is performed by analyzing the ratio of likes and comments to the number of views. Excessively high or low engagement may indicate manipulation. The final score for this layer emphasizes audience criticism and engagement anomalies. The final layer is risk aggregation, which combines all layer score using a weighted sum method. The final score is then categorized into four risk levels: minimal risk, low risk, medium risk, and high risk. The system also extracts red flags from layers with high score and generates actionable recommendations such as warning for user and or the need for further review. Here is a visualization of this algorithm analysis. In conclusion, this multi-layer risk assessment algorithm offers a comprehensive, balanced, and explainable approach to detecting pseudo-expert influencer, although it still has a limitation such as API dependencies and the potential for false positive. This algorithm can be further developed with machine learning, fast-checking APIs, and cross-platform integration. With this approach, it is hoped that the spread of misinformation can be minimized and the quality of public information can be improved. Thank you.